Okay, so we need to first find the temperature rise of the temperature change of the bullet, as well as if the bullet melts given its initial temperature. So we have the mass of the bullet. Mass of lead is going to be equal to 12 grams or 0.012 kilograms. The initial velocity is going to be 220 meters per second, and then the final velocity is going to be equal to 160 meters per second. We know that the bullet absorbs 50% of heat generated. And we know that this specific heat of lead is going to be equal to 130 joules per kilogram per degree Celsius. So if 50% of the heat generated is absorbed by the bullet, we can say that 1/2 times 1/2 mv squared. So it'll 1/2 times essentially half of the kinetic energy that is lost will be converted into heat. And it'll be absorbed by the bullet. So we can say velocity initial squared minus velocity final squared. And this is going to equal Q or mCpB delta T. Now, we have mass here and mass here, so they can cancel out. And essentially, we have delta T is going to be equal to V initial squared minus V final squared divided by 4 CPB. So essentially, we're just taking the change in translational kinetic energy. We're taking 1/2 of that change, and then we're going to set it equal to the formula for the thermal energy. So this will be equal to 220 squared minus 160 squared divided by 4 times 130. And we're getting that delta T is going to be equal to 44 degrees Celsius. So the temperature, so let's be for part A, the temperature of the bullet rises by 44 degrees Celsius. Part B is telling us that we have delta T equals 44 degrees Celsius. Part B is telling us that the initial temperature of the bullet is 20 degrees Celsius. And we know that this is going to be equal to temperature final minus temperature initial. So temperature final will be actually 44 degrees Celsius plus 20 degrees Celsius. So that'll be 64 degrees Celsius. Now, this is much less than the temperature of melting for lead. So that means that none of the bullet will melt because no part of the bullet is greater than the melting temperature for lead. So given this will be your answer for part B. And that's the end of the solution. Thank you for watching.